Namaskar friends, welcome to the 10th session, that is the last session for week 2 of our discussion on the topic manufacturing guidelines for product design. So just to have a brief review of what we have covered, in the very first week our focus was primarily on manufacturing processes. We have tried to understand the process capabilities of the manufacturing processes. Although there is a long list or a big family of manufacturing processes, but we tried to classify the manufacturing processes into important categories, and then we tried to understand that what are the process capabilities of some of the selected processes which are most commonly used for making the engineering products. So, if you remember, we have seen the processes like casting, we have seen the processes like forging, injection molding, compression molding, which are most commonly used for processing of metals and polymers, or we can say plastics. In our second week, our focus was primarily on the materials, because every product that we see around us is usually made up of engineering materials. We have tried to classify the engineering materials, we have seen what are the various categories of the engineering materials, and accordingly we have seen that how to select the best material for a particular application. That may depend upon the function, that may depend upon the dimensional tolerance that is possible with a particular family of material, that may also depend upon the cost, that may depend upon the availability, that may further depend upon the in-service requirements. For example, the product has to be used for aircraft application or aerospace application. We need to have a high strength to weight ratio. In that case, we need to make it lightweight. Therefore, the selection of material will be governed by a lot of factors, which we have already covered in our session number 8 and session number 9, in which the title was selection of materials 1 and selection of materials 2. Today, we are going to see that what type of engineering materials are used for which type of applications, because as a product designer we must have a broad database in our mind where we have this understanding that this particular type of material will be used for this particular type of application. So, if we have the broad idea that for these type of applications these are the materials, then it makes our choice slightly easier. So, that is the target with which we are starting the today's session. So, let us try to see now the different types of engineering materials, their specific properties as well as their specific application spectrum or application areas. I believe that going through today's discussion, a broad picture will emerge in the minds of learners that which type of material can be used or are used for which specific area of applications. For example, we can take the crucibles or the products which are to be subjected to high temperatures. Mostly we will use the ceramics. So, wherever lightweight is an issue, we will broadly go for polymers. So, therefore, this discussion will help you to broadly categorize the materials based on the applications. These are the type of application, this is a specific material which must be used. Now, let us quickly go through the discussion. Now, this is the broad classification of materials which we have already discussed. I think it must be clear on your screen. So, we can see the most commonly used are metals, and metals have been in use since ages. So, metals can further be classified as ferrous and non-ferrous, and in ferrous we have iron, then maybe carbon is added to iron, then we get steel. Non-ferrous we have aluminium, copper, zinc. Then there are ceramics which can be traditional ceramics such as white wares or brick tiles. We can have advanced ceramics which are used for nuclear applications, which are used for optical ceramics. Similarly, polymers, we can have natural polymers like silk, wool, synthetic polymers like nylon, polyester. So, polymers can further be categorized into thermosets and thermoplastic, which we will be seeing in our subsequent slides. Similarly, there are composites which can be natural, for example, the wood, the bones, as well as the artificial such as the metal matrix composite, ceramic matrix composite and polymer matrix composite. So, we see that there is a wide variety of engineering materials which are available with the product designer, and therefore, there is a problem of plenty. Now, the designer has to choose that we have already seen that what criteria, what factors the product designer must keep in mind while selecting the engineering material for a particular product which has to be used for a specific application. So, let us now try to see them one by one regarding metals, what are the specific properties and where the metals are mostly used, and we will take each one of them one by one and we will try to address the specific properties of the material as well as the application or the broad application spectrum of that class of material. For example, we will talk about metals, we will try to see what are the salient characteristics of this family and we will try to see the applications. And similarly, we will try to see all this for the other category of materials also. Now, let us try to go one by one. So, let us first see the metals. So, metals and alloys is the first category of materials that we have listed down when we started our discussion on engineering materials. So, metals are elements which have free valence electrons which are responsible for their good thermal and electrical conductivity. So, this is from the chemistry point of view, free valence electrons, but from the mechanical engineering or application point of view, we need to understand that they are having good thermal and electrical conductivity, and therefore, the wires that are used for conducting the electricity are usually made up of metals. So, metals readily lose their electrons to form positive ions. The metallic bond is held by electrostatic force between delocalized electrons and positive ions. So, this is from the maybe the basics of the metal. The free valence electrons are available which make them good conductor of heat as well as electricity. Similarly, they lose their electrons to form positive ions. So, this is from the chemistry point of view. Then they have a metallic bond which is usually prevalent. So, let us see now what are the general properties. So, that was basic structure of the metals. Now, let us see that what are the properties. So, these properties are much more relevant for a product designer. A product designer may not be that much interested or may not have interest in what is there inside the metal, what type of bonding is there. The chemists or the people who have interest in the chemistry may have that kind of maybe interest, but people who are product designers will be focused more on the properties or the tables which are highlighting the properties of the metals. So, general properties, as we have already seen in the previous slide, for metals is they have high electrical conductivity, high thermal conductivity, and we will see subsequently that these properties will help us to specify various applications for these materials. So, they are ductile. Now, we see that there is a combination of properties that will help us to realize the application for metals. For example, they have high electrical conductivity. Now, for high electrical conductivity, we may use them for electrical wires for conducting the current, but then we need to make the wires, and for making the wires, suppose the material is not ductile, we will not be able to draw the material or the metal into wires or thin wires. So, therefore, the ductility also is important. So, metals have this added advantage that they are ductile, they are good conductors of heat, they are good conductors of electricity, they have relatively high stiffness. Toughness and strength is also key characteristics of the metals. So, they are another point is that they have these properties, whether we will be able to manufacture them properly or not, or whether the manufacturing techniques available for processing of metals. So, we can see they are ready, we can machine the metals, we can cast the metals, we can form them, we can do stamping, we can join the metals using welding. So, therefore, we can see that metals have good characteristics which make them engineering material for a number of applications. So, nevertheless, they are susceptible to corrosion. So, this is a flip side. So, we have to develop our product in such a way that the corrosion does not take place, and for that we may like to coat the metal with some thin coating of paint, or sometime maybe we may like to coat it with another layer which can be deposited using advanced techniques such as CVD and PVD. So that is what corrosion can be taken care of, but the best part is that all these properties that are listed here, they are easy to manufacture. All processing techniques are can be used, are available for processing of metals, and the other characteristics that we have already listed, good thermal and electrical conductivity, ductility, malleability, all these properties make metals as an important engineering material. Now here we can see some of the applications also. These rods can be made easily from metals, these thin wires can be made by metals, then maybe this is these are the metallic powders which are shown here. Threads can be cut in the metal. So metals have, we can say, a lot of application areas, and what are the specific application areas? We can see they are used in structures. In buildings we see we have a metallic reinforcement in concrete. They are used in bridges also. They are used in automobile body, sheet metal body is used in most of the automobiles. They are used in springs, engine block. So they have application in automobile, application in structures, application in airplanes also. The lightweight metals are used there, which in airplanes they can be used for engine components, fuselage, landing gear assembly, and there can be number of other applications. So we are just highlighting some of the applications which are most commonly known to the common people. So trains also, all of us travel by train. In trains we see rails, engine components, body, wheels are mostly made up of different types of metals only. Similarly, the machine tools or the machines we see around in the workshop are made, the drill bits, tools also. So this is from the tools category. Hammers, screwdrivers, saw blades, the machine beds, all are made by metals. Electrical wiring, I have already given an example, magnets. So there is a long list of metallic components. Even these are all engineering applications we are giving. When we sit to eat food, we sometimes use a stainless steel plate, which is also a metallic alloy. So similarly, we can see metals around all of us. If we ride a bicycle, we will see the body is made up of a metal. So there are number of applications where the metals can be used. And now after going through this session as a product designer, some idea will be framed, some thought process will develop that yes, metals can be used for these type of applications. Some of the applications are listed here. So wherever strength is required, toughness is required, stiffness is required. So wherever good thermal conductivity is required, good electrical conductivity is required, in those cases we will definitely suggest the use of metal as an engineering material for product design. Now let us see the second category, that is these are the ceramics. Now in ceramics we can see they are inorganic, non-metallic crystalline compounds. So they are non-metallic. So obviously the properties that we have listed for metals, ceramics will not have all those properties, but ceramics will have their specific or special characteristics which can make them a engineering material. Now some of the examples are given, it must be written like this: silicon dioxide, Al2O3, magnesium oxide, titanium dioxide, then barium oxide, number of examples are there. So all these examples fall under the category of ceramics. Now some literature also include glasses in the same category. However, glasses are amorphous. So here we say they are crystalline. Most of the ceramics are inorganic and crystalline, but glasses are amorphous, but they are also broadly included in the ceramics category only. So compound, they possess short range order of atoms. So they are amorphous in nature. Now, what are the general properties? So, we are not going more into the chemistry of each and every engineering material, we are going more into the application part, and applications depend upon the properties that the material possess. So, there can be structure property correlation also, but that is an advanced topic which maybe as a product designer we may try to study or like to study after gaining the basic information about the engineering materials, because we have seen in metals free valence electrons. So, that is the chemistry point of view, and this chemistry influences the properties that we have seen, and the properties influences the application. So, or influence the application. So, here also we are on the second and the third stage, we are focusing on the properties as well as on the application. So, what are the salient properties of the ceramics that we can see here? They are hard, they have high strength, they are stronger in compression, but not that good in tension. So, they are brittle in nature, low electrical conductivity. So, you see for metal this low was replaced by high in case of metals. So, in case of metals this low is replaced by high. So, high means that in metals we have high electrical conductivity, whereas in case of ceramics we have low electrical conductivity, which means we can select metals where the electrical conductivity has to be ensured, or the application where we require high electrical conductivity, and wherever the electrical insulation is required we can choose the ceramics because they have poor electrical conductivity or low electrical conductivity. So, the temperature resistance is another property. As I have already told, in crucibles usually we use the ceramics only. Similarly, they are corrosion resistant, whereas in case of metals we have seen that corrosion is a problem. So, how we can club these two things together? The metals are prone to corrosion, the ceramics are not prone to corrosion, they are corrosion resistant. So, what we can do? We can make a metal, and we require toughness, stiffness, strength, everything in our product. So, what we can do? We can select metal as a substrate, we can make the product of or a metallic product using a specific metal, and then we can coat the metallic product with the ceramic coating. So, the ceramic coating will make it, ceramics are corrosion resistant. So, the coating will make the product corrosion resistant, whereas the metal will give, which is the substrate or the main integral part of the product, the metal will itself have high toughness, high strength. So, we will be able to club the best properties of the two materials. We have taken the best properties of the metal, we have taken the best properties of the ceramic, and we have combined them together to develop a third material which will give us better properties. It will be good in strength, good in toughness, stiffness, whereas it will also be corrosion resistant because of the coating given of the ceramic material on the surface of the metal. So, therefore, many times we combine 2 or 3 different materials together to take advantage of the best properties of these materials, and that is where the concept of composites come into picture. So, let us now see, we will come to the composites towards the end of today's session, but let us now see that based on these general properties what are the application areas of the ceramics. So, here we can see some of the applications, pictures of the ceramics. Small components are usually made with ceramics, and there can be different manufacturing processes for making of ceramics. For metals, if you remember in the today's slide only, we have seen that metals can be machined, metals can be casted, they can be forged, they can be extruded. So, they can be drawn into thin wires, they can be beaten into thin sheets. So, metals have all the manufacturing processes applicable to them. Whereas for ceramics there are specific processes that are used for processing of ceramics. One of them can be a powder metallurgy, and there can be other techniques also that can be used for processing of ceramics. And if you wish to have a discussion on this particular topic, how ceramics can be made, we have already recorded sessions on processing of non-metals, in which we have focused on the processing techniques for ceramics. But the title today or the course that we are currently discussing, that is manufacturing guidelines for product design, we cannot have a liberty to discuss that how ceramics are manufactured. So, our focus primarily is to list down the application spectrum of ceramics, that in what type of applications they can be used. So, let us see now where they can be used based on these properties or general characteristics that they possess. So, ceramics, as we can see, there are fine ceramics, cement, pottery items, glass, refractories which are used for high temperature applications. So, as I have already told, as they are poor conductors or low, they possess low electrical conductivity, therefore they are used as electrical insulators. Thermal insulation and coating, this is another application because they are poor conductors of heat also. They are used, if the glasses we see, glasses they are used in windows, television screens, they are used as optical fibers. Then as they have resistance to corrosion, they are used for corrosion resistant application. They are used in electrical devices such as capacitors, transducers. They are used in highways and roads as concrete. They are used as building blocks such as bricks, building binders such as cement and gypsum. They are used for biocompatible coatings, as I have already done fusion on the bone. Even the white cement sometimes that we use for teeth also is a ceramic material. They are used as magnetic materials, audio video tapes, hard disk. So, you can see the properties we have seen: corrosion resistance, poor thermal conductivity, low electrical conductivity, high compressive strength. So, all these properties lead to these specific applications. So, now we can keep a galaxy of application, or we can keep a library of applications in our mind, that which are the specific application areas for ceramics. So, once we are designing a particular product, we know the product is being designed for this particular application, we can very easily single out ceramics for that particular application if it matches the service requirements for which the product is being designed. So, we have seen two different types of engineering materials by now. The first one were the metals. We have seen the specific application areas of metals. Second is ceramics. We have seen the specific application area for the ceramics. Now, let us move to the polymers. So, a polymer is a long chain molecule, because the word poly itself explains that. A polymer is a long chain molecule made up of many repeating unit called monomer. So, different monomers, when they polymerize, they make a polymer. Polymers can be natural or they can be synthetic. So, there can be natural polymers, there can be synthetic or man-made polymers, such as we can say nylon or polypropylene or polyethylene. There can be number of synthetic polymer. We will see the examples in the subsequent slides. The properties of polymers are linked directly to their structure, which is dictated mostly by the intermolecular bonds. So, this is again from the chemistry point of view, that the intermolecular bonds in the polymer will influence their properties, and these properties will subsequently affect their application areas. Now, based on the kind of bonding that is developed during the process of polymerization, we can have thermoplastics and we can have thermosets. Now, depending upon the polymer being a thermoplastic, it will be used for specific applications. Similarly, polymer being a thermoset, it will be used for specific application because of the intermolecular structure inside the polymer. So, examples are, polymers are everywhere. So, if we see in the normal this classroom only or the recording studio, if we look at the various applications or the various products that we are using here, at least we can list down 10 to 15 different products which are made out of polymers. In I am using a pointer or a slide changer as well as this stylus, both are made up of polymer. So, two products currently I am using. Third, the pen I am carrying is also having a plastic body. So, we can see just in and around only 3 products of polymers we have seen. So, polymers are everywhere: bottles, toys, packaging, cosmetics, other hair care products, contact lenses, and in nature also crab shells, amber. In food also polymers are there, protein, starches, gelatin, gum, gluten, and then the fabric balls, sneakers, and even in our DNA. So polymer we see all around us, the spectacles that we are using, many times the frame will be made up of a plastic because they are lightweight materials. So wherever the weight is an issue, definitely we will like to propose the use of a plastic material. Now polymers, as I have already listed, they can be thermoplastic and they can be thermoset. Now thermoplastics, we can see mostly the toys that we see for our children are made up of thermoplastics. These are the building blocks shown here. So they can be melted repeatedly. So which means that we can recycle the thermoplastics, whereas thermosets, once they are shaped, they cannot be remelted or melted again. So we can see many of our electrical installations or the polymer that we use for making the shoes and the switches, electrical switches, if there is a short circuit, it will burn, it will not melt, it will not drop down as a polymer again, but it will, what it will do, it will burn out. So which means it cannot be remelted again. So the thermosets cannot be remelted or reshaped again, whereas thermoplastics can be melted repeatedly. Now thermoplastics examples are given here: polyethylene, polymethyl methacrylate PMMA are composed of linear polymer chains. They flow under shear when heated. They can be compression or injection molded. So the processes are also listed here, that thermoplastics can be made by compression molding process, they can also be made by the injection molding process, and these parts which are shown here blue in color must have been made by the injection molding process. Whereas the thermosets such as polystyrene, polyvinyl chloride are composed of branched polymer chain. They do not flow when heated, but they will burn out on excessive heat. The monomers are cured in a mold. So they are, we can see these are molded. Thermoplastics are molded, whereas thermosets are cured. So chemically we accelerate the polymerization process by adding a hardener, and then after a sufficient amount of time, as depending upon the type of thermoset we are using, they will get solid or they will get cured. So that is the differentiation between thermoplastics and thermosets, and that dictates the application areas for which we are using them. So as a product designer, when I have to choose a polymer, within polymer also I must see that whether I must use a thermoplastic material for this application, or I must propose a thermoset material or a thermoset polymer for this product. Now what are the general properties? So these are in comparison to the metals. Polymers have lower density, lower stiffness, and they tend to creep. So their density is low, therefore they are used for lightweight application. Stiffness is also low and they tend to creep. High thermal expansion and corrosion resistance. So they can be used for corrosion resistance, whereas there is a tendency of high thermal expansion. So low electrical and thermal conductivities, which is also a property that we have seen for ceramics, low electrical and thermal conductivities. The prime weakness is that polymers do not withstand high temperatures. So that is one major problem. So wherever high temperatures are there we will propose the use of ceramics, or depending upon the temperature, the metals. Polymers are not used for high temperature applications, they are used for low temperature applications only. So these are the salient properties of polymers which will dictate their application areas. Now when you see any plastic product, for example I see this pointer or a slide changer, we will see that it is not going to be subjected to a very high temperature. We do not require high thermal conductivity. We don't require high electrical conductivity in this product. So whatever properties that are listed out here are suitable for making this in a plastic material. So therefore, depending upon the application, we will see that what are the properties that the engineering material possess and what can be the specific application area for that particular engineering material. Now applications, we see plastics all around us. 3 examples I have just given you. So they are used for clothing and upholstery, vinyls, polyesters, nylon, moldable products like computer casings, telephone. They are used for biomaterials, water resistant coatings, low friction materials, that is Teflon, adhesives and glues, where many times we use glue to join the plastic parts that are broken. So many times to join wooden parts also. So those glues are nothing but they are polymers. They are used for containers, example is shown here. They are used for liquid crystal, synthetic oil and greases also are polymers. Soaps and surfactants are also polymers. So polymers also find a lot of application. To just emphasize on the importance of polymers, we can see that there are institutes which teach only about polymers science and engineering. So you can get your degrees even in polymer science and engineering, and that justifies the applications of polymers. But nowadays there is lot of focus on the waste disposal and recycling of the polymers, and that is a big concern in which the world fraternity as well as the engineering brotherhood is trying to find out solutions. Even the government is going to pass regulations or is in the process of passing regulations to minimize the use of polymers which are non-biodegradable. So the focus now in future is going to be for developing the polymers which are biodegradable as well as recyclable. Finally, we come to the last category, that are the composites. Now a composite is a combination of 2 or more materials to achieve better properties than that of the original materials. So suppose the original materials are X and Y. So when we want to develop a composite material, we will like to take the best advantage of X and Y, the properties, and then develop a new material Z which is having the best properties of X and Y. And one example already I have told in the beginning of today's session, that when we require high strength and stiffness as well as toughness, we take metal, then we coat it with a ceramic to make it corrosion resistant. So that is, you are combining 2 different materials together to develop a third material which is going to give you the best properties of the 2 individual constituents. So these materials are usually composed of a matrix and 1 or more of a filler or a reinforcing material. So the primary objective of engineering composites is to increase strength to weight ratio. So this is specifically increase strength to weight ratio for one specific family of composite material, that is the polymer matrix composites. We have other types of composites also, like metal matrix composites, ceramic matrix composites. So we will see what are the general properties of composites. They have low weight, high stiffness, brittle when we talk of the thermosets as the matrix material. In case of thermoplastics, they are not that brittle. They have low thermal conductivity, high fatigue resistance. Their properties can be tailored according to the component material. Now depending upon the final application, we can choose the type of the matrix that we are going to use, the type of the reinforcement, the type of the filler. Then we can even decide on the number of layers that we are going to use for making a composite material. We can decide the material for each layer also. So composite is also a very big family in which further classification is there on terms of the matrix and in terms of the reinforcement that we use. Now the composites, we can see the application area of the composites. They are used in sports equipment, golf club shafts are made by composites, tennis rackets, bicycle frames. Then smart materials, they are used for sensing and responding. Aerospace materials, they are used for lightweight applications, because already we have seen high strength to weight ratio is one advantage that we have with the composite materials, specifically with the polymer matrix composite materials, and therefore they are finding lot of application in the aircraft industry. Thermal insulation, concrete, we can have brick materials. So composites are also finding lot of application all around the globe, and in future they are further going to be used to satisfy the human needs and requirements. So with this we come to the conclusion of our discussion on engineering materials, and that is the closure for the week 2. In week 3 we will start discussing the other aspects related to the product design, specifically related to the manufacturing guidelines for product design. So in today's session we have tried to see the basic properties of 4 different types of engineering materials and the application areas related to the properties of these materials. We have covered metals, ceramics, we have covered polymers as well as the composites, and with this we conclude the second week of our discussion. Thank you.